Challenge activity 4.2.2. Now we're talking about z-scores. So remember, there's a normal distribution, then there's a standard normal distribution. A standard normal distribution is just a special normal distribution, not oxymoronic. But anyway, standard normal means that it's a normal distribution with a mean of 0 and a standard deviation of 1. So back before you could use Excel or you could use other statistical tools to easily find these probabilities, we used to have to use an old lookup table. Now you guys have a lot more options, but in the lookup table, you had to what I call normalize it or standardize it to convert it to a z-score instead of a instead of the variable. So if you had like a mean of 100, you needed to standardize it so that it was now a mean of 0, so you could use the standard normal distribution table. So we're going to go through a little bit of that in this example. A football coach finds that player run times for a 50-meter dash are normally distributed. A new player runs a time with a z-score of -2. What does this result indicate? So right there, when we hear z-score, we know we're looking at a standard normal distribution. Remember, that mean is 0. So if we're looking at it on like this, it's 0. So what we're saying is that this person ran with a z-score of -2. Now, since the mean is 0, we already know that that means that this is less than or below the average. If it was positive, then it would be greater than, or if it was really close to 0, we would say it was about the same. But it is definitely less than because it's -2. Let's check. Nice little green. All right, let's go to the next one. We have new employees at a company are given a proficiency test. The test scores are approximately normally distributed with a mean of 350 and a standard deviation of 20. So here we are normally distributed, but it's not standard normal because our mean is not 0. A new employee scores 370 on the exam. What is the employee's z-score? So what we're saying is if we were to standardize this variable, so let's say we have this variable x, that's that 350 where the mean is. Let's say we have this variable that's x. So all these employee scores are x equals something. What we want to do is now convert them to a z-score where they are now standard normal with a mean of 0. So the way we do that is by using this formula. So we have z equals x minus mu over sigma. So we're given from the problem right here that mu is equal to 350 and sigma is equal to 20. All right, so we just need to plug those numbers in, and we also know that our x is equal to 370. That's the number right here that we're trying to standardize. So we're just going to plug these in. So we have 370 minus 350 over 20. And one thing I want to point out here is that it's going to be a positive number. See that? We have 370 minus, that's going to be a positive number. That's what we want. We want it to be positive because we see right here that this number is bigger than our mean. That means we should have a positive number. If we end up with a negative number, it means that our x right here is less than our mean. All right, so we subtract that. We get 20 over 20, which equals 1. So that means our, if we were to look at it here, let's make this a little bigger. If we were to look at it here, oh, that's terrible. There we go, a little better. That would be our mean, right, at 0. 1 would be up here, that's plus 1 standard deviation, right? Okay, so let's go ahead and plug that in. We have 1, let's check our answer. Nice little green check mark. So that's how you standardize to find the z-score. So if you have any questions about that or anything else, let me know.